Hello guys, welcome once more to class online. Now, if you have any question, if you have you ever wondered what is the mirror formula? Now we have a mirror question in this series, which are looking at Jamb Physics 2014, question number 26 to number 13. And also, I have a formula in wave that I always believe is the strongest formula. That I believe it is a formula that you can hardly take any past question for on any year, and they ask you wave question and they won't ask you for that formula. That formula is, I always call it the strongest formula for one reason. It cuts across many aspects of physics. It's a single formula, it is under wave, and it cuts across many aspects. It cuts across introduction to wave, it cuts across photoelectric effect, it cuts across echo, that's under sound. So the formula can help you to answer any question on wave within this domain. So that formula, I notice it comes out almost every year. So, and that will also be seen in this video. And in this video, that formula appears in 3 questions on back to back. It was used to solve 3 questions that follow themselves back to back. And that tells you that the formula is truly very important. I always call it the master formula for wave. Now let's get to it now. Now don't forget that if you learn anything from this video, click on like button and we'll get to reach you with more content that will better help you understand physics. My name is Tutor Danny. Now let's go to number 26. The distance between 2 successive crests of a wave is 15 centimeters, and the wave and the velocity is 300 meters per second. Okay, calculate the frequency. Now the only formula to use now here is the master formula, and here it is: V equals F lambda, where V is my wave speed or velocity, then my F is my frequency, and lambda is my wavelength. This little formula is the strongest formula in wave. I can always say that, and I always say that. It looks simple, but it can save you a lot of questions in wave. This formula can save you, so I would advise that you don't forget it. Now we are told to find here the frequency. So I'll make frequency the subject by dividing both sides by wavelength, and I'll have frequencies therefore V over wavelength, right? Now what's my V? My velocity is 300, and my wavelength is the distance between 2 successive crests. Now this statement, distance between 2 successive crests, is wavelength. That is the definition of wavelength. But they did not say wavelength. They just said distance between 2 successive crests. That is actually wavelength, and that is the meaning or definition of wavelength. So therefore, I'll just plug it in. 15, but it's in centimeter. Turn into meter divided by 100. That's times 10 to the power minus 2. That's how you change centimeter to meter. So I have 300 divided by 15 is 20 times 10 to the power. This minus 2 will go up and become, it will lose the minus. Whenever 10 to the power something goes up, it will change sign. So it will change from minus to plus. 10 to the power 2. 20 times 10 to the power 2. That will give me, if I move this point from here to standard form, move the point from here to the back of 2, that will give me 2 times 10 to the power 3, because this 2 will add 1 to become 2 times 10 to the power 3 ends, and that is the frequency. Let's take our number, that's B. And number 27 said what? Let's take out number 27. A boy receives the echo of his clap reflected by a nearby hill 0.8 seconds later. How far is it from the hill? Now this is excuse me, this is the same formula working for echo. Now V equals F lambda. That's what I told you before. It can also take a modification a little by, you can also change this lambda to 2 times D and your frequency to 1 over period. You know, frequency is 1 over period, right? That's frequency. But you can, the formula can change these two guys, frequency and wavelength, into 2D for wavelength, and frequency is 1 over T, and that will become 2D over T, and that is just it. Now it can be either this one or this one, but in this case they are talking about this one. That means I'll be using this one. Okay, that will become V equals 2D over T, and I'm trying to find how far, that's distance. So I will cross multiply. I'll be saying 2D equals V times T. Okay, now what is the V? There is no speed mentioned here, but this is a sound wave. Now whenever you are dealing with sound wave, the speed is always a constant. 340 meters per second is the speed of sound. It should have been in the question, but it is not there. So we just have to know it offhand. The speed of sound is 340 meters per second. Okay. Then my time in the question is 0.8 seconds divided by 2. And if I multiply this and I divide by 2, I'll get 136 meters as my distance. And that is the way to go. B. Let's check number 28. The diagram above shows a stationary wave of wavelength 40 centimeters in a closed tube. The length L of the resonating air column is what? Now this, because they mention wavelength and they are saying find the length, and length means distance, you can also use the same formula again the third time. V equals F lambda equals 1 over T. Of course, F is 1 over T. Then lambda is 2D. So an applicant lambda is 2D, and therefore wavelength is 2D, because lambda means wavelength. Okay, is 2 times distance or length. Distance is the same as length. So that will now give me, to find my length, I will just divide both sides by 2. So D, or length, is equal to lambda or wavelength over 2. And that will give me 40 over 2 as 20. And therefore my answer for number 28 is 20 centimeter. B. Number 29. An object is placed 10 meters from a pinhole camera of length 25 centimeter. Calculate the linear magnification. When it comes to camera, pinhole camera, you must know that magnification can also be given as camera length over object distance. Although we know it as the image distance over object distance, is the same thing as camera length over object distance. And that is the formula for anything magnification. Okay, now what's the camera length in the question is actually 25 centimeter, but it should be in meters. So to change from centimeter to meter, 25 times 10 power minus 2. Okay, because it is like you are just dividing by 100, and that's divided by 100 means 10 to the power minus 2 over the object distance is 10, and that's 25 times 10 to the power minus 2 over 10. So if you do that, you'll be getting 25 by 10 is 2.5 times 10 to the power minus 2. I will not touch this 10 to the power minus 2. I only divided 25 by 10, and that's 2.5 times 10 to the power minus 2 is my magnification, making A the correct answer. Number 30, the last one. The focal length of a concave mirror is 2 centimeters. If an object is placed 8 centimeters from it, the image is at what? Now look at this now. 30 centimeters in 2 centimeters is the focal length, but the object is 8 centimeters. Now this is a mirror question. When you are hearing focal length, you are hearing object placement or distance, you have to find image. That is a mirror question, right? Now let's take a look at the mirror formula. This is the mirror formula: 1 over F equal 1 over U plus 1 over V, where F is my focal length, U is my object distance, and V is my image distance, right? Now you have to find the word image, right? That means you are finding V. So to make V the subject is the first thing I must do. Now, how you do that? FUV. Put FUV, that's the LCM, beside everything. FUV, FUV, FUV. F cancel F, U cancel U, V cancel V. So I'm left with UV equals FV plus FU. Now I'm to make V the subject, so bring V to V. So UV, this FV will come here and become minus FV equals FU. Then V is common, factorize, V is common. So V will come out, it will be left with was U minus F. Then bring this U minus F under the FU. To become V, therefore is what? FU over U minus F. So I've successfully made V the subject of formula. Now plug in the value that they are giving the question. My V, therefore, what's my V? My F is 2, and my U, that's the object distance, is 8 over U, 8 minus F, 2. 2 times 8 is 16. 16 over 8 minus 2 is 6. 16 over 6 is 2.7. And that is the answer, 2.7 meters. And that is how to find the image distance in a mirror question. Any day, anytime. Don't forget the mirror formula is super important. Let's go on. And that brings us to the end of this video. Don't forget, if you learned something from this series and you want more content, like us, click on like button. We'll get to reach you with more content that will better help you understand physics. Until we see you again, guys, take care of yourself and bye for now.